Hello everyone, and thanks for being here with us today. In this video, we focus on the challenge of avoiding invasive code modifications or minimizing them for instrumentation. We'll explain why modifying the application code can be problematic and how SoftScanner addresses this issue. So let's dive into what this challenge means and how to overcome it.
So traditional instrumentation for continuous quality assessment is often invasive as it involves manually inserting code snippets throughout the application, as we can see over here, for instance. So this approach, although effective for data collection, it can lead to code tangling and it makes the application difficult to maintain as it evolves. So every time the application is updated, these scattered instrumentation snippets may require manual adjustments, which increases the risk of errors and hinders scalability. Moreover, when this instrumentation is tightly coupled with the application source code, it becomes challenging to evolve the application and the instrumentation independently, which can ultimately limit the flexibility needed for continuous quality assessment, especially as web applications grow in complexity. So if you look at this application, for example, you can see that we have a lot of different components over here. And if we're interested, for instance, in capturing specific events like clicks, then we would have to go in the source code of all of these components in order to see where this data could be collected. For instance, in the new post, we can go over here and we can see that we have a submit button. So we have to add the necessary instrumentation over here in the component in order to capture that event. And the same could be said about the other components. So imagine if this application keeps on evolving, this means that we have to modify and verify each added instrumentation snippet and verify that it evolves appropriately, which could lead us sometimes to forgetting one component or one specific point in a given component, and this could lead, as you see, to errors, and it could become easily time consuming and hard to maintain and scale. So to resolve this, non-invasive instrumentation tools were created where instrumentation is modularized into separate files. As we can see, for example, over here, using aspect-oriented programming, we separate the instrumentation logic into its own file while keeping it separate from the actual Codebase application file. So this allows us basically to get rid of the tight coupling between these two elements, and they allow us basically to evolve and scale both independently. However, there's also a limitation with these approaches, is that the instrumentation files still need to be created by technical stakeholders, as we see over here, application developers, and by default, these non-invasive instrumentation tools have no explicit link to the continuous quality assessment of web applications and therefore need to be adapted accordingly by the technical stakeholders.
So to address this challenge, SoftScanner automates the development and deployment of non-invasive instrumentation into the application. Instead of modifying the source code in multiple places, SoftScanner uses an automated instrumentation framework that injects the necessary instrumentation into a single entry point of the application. Based on the application metadata, the selected goals, the mapping model of SoftScanner identifies the required metrics and observable data, then provides them to the instrumentation manager. So the instrumentation manager then selects the appropriate generator and injector for the target environment. The generator creates instrumentation files tailored to the required quality metrics by leveraging the APIs of existing tools like OpenTelemetry or aspect-oriented programming, and uses an instrumentation bundler to bundle these files using tools such as Webpack or EASBuild appropriately. And finally, the instrumentation injector deploys the instrumentation agent into a single designated entry point, ensuring that the application code remains untouched. This non-invasive approach decouples instrumentation from the main application code, making it easier to maintain, scale, and update the system. So as a result, stakeholders benefit from a robust quality assessment solution without the risks associated with manual code modifications. Now let's check the SoftScanner platform to see how this is done in practice.
So in this scenario, we assume our stakeholder is interested in assessing some quality goals for their Angular front-end web application. Now, since I've already provided the metadata of the application, we can simply just take a look at its repository. And as you can see, it's still fresh and it hasn't been touched by SoftScanner thus far, as indicated by VS Code. So let's get back to SoftScanner and simply select user engagement, for instance, for our application. I'll select it with all the goals, and then I'll start the quality assessment process and we'll wait for the instrumentation to finish. So now that the instrumentation is complete, let's see the instrumentation files that were generated and the instrumentation bundle and see how it was injected into the application. So if we take a look at the assets folder in here, see that we have an instrumentation folder and a bundles folder. If we look into the instrumentation folder, we'll see that we have an instrumentation folder for the Angular application and for other applications that we did previously. Now, if you take a look at this application, this folder, we'll see that we'll have an actual project containing the instrumentation files for our application, along with the necessary configuration file. And if we examine the content of these instrumentation files, here for instance, we see that we have an instrumentation using OpenTelemetry dedicated for our application. All of this have been created automatically by SoftScanner with the corresponding collector and span processing necessary for capturing the necessary data for the quality assessment. And we can also see that the necessary events have been also specified to capture this all of the necessary user interactions to assess quality assessment. So this instrumentation is then bundled into, as we can see over here, different folders for different applications, and we can see finally the actual bundle that was created from our instrumentation files. Now this bundle has been copied and placed within our test application, instrumented application, which is an Angular application. And as you can see from VS Code over here, first of all, we have a modification in the index.html, where we have a single script that injects this bundle into the main template of this Angular application. And this bundle is actually located in the assets folder within the bundles folder of this application as well. So now that we've seen how this behavior works for Angular, let's see another scenario with a backend application using Node.js, for instance, to see how SoftScanner will adapt its instrumentation accordingly. So in this scenario, we assume our stakeholder is interested in assessing some quality goals for their Node.js backend application. And we can see here that the repository of the backend is still fresh and unmodified by SoftScanner as well. Now, since I've already provided the metadata for this application, let's simply select, for instance, time behavior, and let's start the quality assessment accordingly. And now we'll wait for the instrumentation to complete. Now that the instrumentation is complete, let's see the instrumentation files that were generated, the instrumentation bundle, and see how it was injected into the backend application appropriately. So if you take a look at the generated instrumentation, you will see in the instrumentation folders underneath the assets folder in the SoftScanner backend that now we have a set of instrumentation files that are used to instrument our backend. And you can see here that we're also using OpenTelemetry, but this time we're using the Node Tracer provider, whereas for the Angular application, we used a Web Tracer provider. So the same thing has also been done for these instrumentation files, as now we can see that we have an instrumentation bundle for all of these files. Now what we did is similar to what we did with Angular applications. We simply copied this bundle, and then if you take a look at the back end, which is now modified, you can see that we have a new folder called assets where we have copied this bundle. And then if we take a look at package.json, we will see that we have a change in the start script where now we include the actual bundle as part of the building of the backend application. So now when we call npm start, if I stop this, we will actually see the new bundle being called when we actually build our backend application. And then when we run it, we will see that happening appropriately. So in summary, SoftScanner's non-invasive instrumentation offers several critical advantages. First of all, it automates the generation, bundling, and deployment of an instrumentation agent to collect the required data for the selected quality goals. As such, it eliminates the need for stakeholder technical expertise while reducing their efforts and avoiding their errors. It automatically leverages and customizes existing rule-based instrumentation patterns like AOP, aspect-oriented programming, and observability tools like OpenTelemetry for the generation of the instrumentation files. It also automatically bundles these files into a single deployable agent to optimize their size and facilitate injection into the application. Then, by deploying the bundled instrumentation agent at a single centralized entry point, it eliminates the need for scattered code modifications. This approach simplifies scaling that quality assessment requires along with the application evolution. And it ensures that the instrumentation logic remains decoupled from application logic, making the risk of introducing errors during updates much more minimal. Moreover, this makes it easier to scale the instrumentation as the application loads fluctuate by simply injecting the bundle into every new instance of the created application when and if required. Finally, thank you for watching, and stay tuned for more insights into SoftScanner and continuous quality assessment of web applications in the near future. See you soon.